Imagine you're hours deep into prepping a massive, high-stakes presentation for a client.
Oh, the classic nightmare scenario.
Exactly. You've got 20 different screens laid out on your canvas.
Yeah.
You are meticulously aligning a complex checkout flow, right? Making sure every single pixel is absolutely perfect.
Uh-huh.
Then suddenly, without any warning whatsoever, every single Buy Now button on your entire screen shrinks by 10 pixels.
And probably turns neon green or something.
Yes. Bright neon green. Your text alignment completely shatters. Your margins collapse.
Just ruined.
The layout is totally ruined.
Yeah.
And it happened because a designer on another team, sitting in a totally different building, hit publish on a shared file you didn't even know you were linked to.
Yeah, it's terrifying. But honestly, it's incredibly common when companies start scaling up their design operations without a solid underlying architecture.
Well, today we are talking about how to prevent that exact disaster, and more importantly, how to take control of the living, breathing ecosystem that is modern interface design. Welcome to the deep dive.
Glad to be here.
So, that scaling bottleneck is exactly what we're here to solve today. Our mission really is to crack the code on how to stop doing the redundant, soul-crushing work of designing the exact same drop-down menus and buttons over and over again.
Right, moving away from pushing static pixels.
Exactly.
Right.
We want to build scalable, intelligent systems. And our guide for this is a phenomenal, wildly practical source. We are breaking down the core design concepts from the chapter Building Design Systems out of the book Designing in Figma, a masterclass in modern interface design.
It's such a great book.
It really is. We are going to explore the mechanics of bridging the gap between design and development.
And the overarching philosophy of that book, particularly from the author, Alla Kolmatova, is that without a shared design language and shared technical practices, collaboration doesn't just become difficult, it actively works against the product.
Real quick, to you listening, if you're a learner who wants more of these technical design breakdowns and you want career-building content to level up your workflow so you can stop doing repetitive busy work, make sure you hit follow and subscribe to the show. We love putting these deep dives together for you.
Yeah, please subscribe.
Okay, let's unpack this. If you walk into literally any growing tech company, you hear the exact same frustration. Designers feel like assembly line workers.
Yep.
And developers are just exhausted because they're staring at custom styling, messy code bases, trying to interpret why there are like 20 slightly different shades of gray across 20 slightly different modals.
Right, and the solution to that friction isn't just to work longer hours.
No, definitely not.
The solution is to treat your design tools as though they are heavily influenced by software engineering.
Wait, so I have to learn to code?
No, you don't need to write production-level JavaScript to use a design tool like Figma. But familiarizing yourself with the core concepts that back-end and front-end developers have relied on for decades, that is the secret to scaling your value as a designer.
Which brings us to the foundational building block of this entire system. If we want to solve the repetitive workflow nightmare, we have to look at the absolute base atom of Figma. The component.
The component.
A component is basically an object that you can reuse across an entire project. It lets you split a massive, overwhelming interface into independent, maintainable pieces.
Exactly.
But to really grasp why Figma's approach to components is so revolutionary, we need to look back at how we used to work. Like, design applications have had the concept of symbols for a long time.
Yeah, you could turn a logo into a symbol in older tools, but they were incredibly rigid.
Right.
They were essentially just rubber stamps. You could stamp that logo onto 50 different pages, but if you wanted one of those logos to be white instead of black-like, to sit on a dark background, you had to break the symbol apart.
You had to sever its connection to the master file.
Exactly.
Yeah.
It wasn't smart at all.
Yeah.
And the turning point for this didn't actually come from the design world.
It didn't.
No, it came from the engineering world. Right around 2014, the programming framework React just exploded in popularity for building web interfaces.
Oh, right. React fundamentally changed the paradigm. Because before React, developers were building web pages as massive, single documents.
Yeah, exactly. If you wanted to change the header, you had to manage the code for the entire page. React introduced component-based development.
So developers suddenly had full, granular control over both the visual presentation and the interactive behavior of individual modular components.
Right. A button wasn't just a picture of a button anymore. It was a self-contained package of logic.
And when designers, especially those who dabbled in front-end coding, saw the power and flexibility that React gave developers, They looked back at their static design tools and realized how painfully antiquated they were.
Yeah, drawing static pictures while engineers were building living, breathing component architectures felt like a massive disconnect.
And the timing for Figma entering the market was just impeccable.
Oh, perfect timing.
Yeah.
Because they were building their architecture from scratch in a post-React world, they were able to avoid all the legacy technical debt of older applications.
There's actually a great point from Rasmus Anderson, a principal designer at Figma, about this era. He noted that users today expect modern interfaces to be alive, to be connected, and to constantly evolve.
Right.
But designers were still functionally drawing static oil paintings. Figma's entire premise was to give designers the exact same modular engineering-grade capabilities that the developers already had.
And that philosophy manifests on the canvas through two distinct interconnected concepts,
Which are?
the main component and the instances.
Okay, I find the easiest way to conceptualize this is through a manufacturing lens. Think of the main component as the original master mold in a factory. It dictates the shape, the dimensions, the fundamental truth of the object.
I love that analogy.
And the instances are the castings that come out of that mold. They're the clones.
That framework holds up perfectly when you look at how Figma visually distinguishes them in the interface. Figma goes out of its way to ensure you never confuse the mold with the casting.
How so?
Well, if you look in your Layers panel on the left side of the screen, the main component is marked by a very specific icon. It looks like 4 small diamonds clustered together into a larger diamond shape.
Oh, right.
And the text of the component's name is rendered in a heavy, bold font.
And the clones, the instances?
They get a single hollow diamond icon, and their text is regular, unbolded weight.
Got it. But the dead giveaway, the thing you notice immediately on the canvas, is the color purple.
Yes, the purple.
Regular frames, text boxes, and shapes in Figma have a standard blue bounding box when you select them. But the absolute second you convert a group of layers into a component, that bounding box shifts to a distinct, vibrant purple.
It acts as a constant subconscious visual reminder that you are no longer manipulating a raw, isolated graphic. You're manipulating a linked, systemic object. Any change you make here is going to have ripple effects.
And creating that master mold is totally frictionless. You select a button you just designed, you hit Option-Command-K on a Mac, and the bounding box turns purple. You now have a main component.
Yep, it's that easy.
To generate the clones, the instances, you can duplicate it with Command-D, you can hold the Option key and drag a copy of it, or you can drag it straight out of your Assets panel onto a new screen.
Exactly.
But here's a workflow reality that used to cause me immense anxiety when I first adopted this system.
Let's hear it.
What happens when you are deep in the weeds, looking at an instance of a navigation bar on, screen number 42,
Oh, no.
and you realize the master mold needs a structural padding adjustment, but you have absolutely no idea where you left that main component in your sprawling, chaotic file?
That is the classic needle in a haystack problem of design systems. It happens to everyone.
It's the worst.
But Figma built a lifeline specifically for that panic moment.
Yeah.
When you select any instance on the canvas, you can look over at the Properties panel on the right. Right at the top of that panel is a small target icon that says, Go to Main Component.
Ah.
Click that, and the camera instantly whips across your document, teleporting you directly to the master mold, highlighting it, and centering it on your screen so you can make your global edit.
While that feature is a lifesaver, I do think we need to talk about the messiness of the canvas itself.
Sure.
Because by default, when you highlight a button and hit Option-Command-K, Figma converts it to a main component and just leaves it sitting right there in the middle of your mockup.
Right.
Older legacy tools used to forcibly whip symbols off your active canvas and banish them to a dedicated hidden symbols page to keep things tidy. If we just leave master molds scattered wherever we happen to create them, doesn't the file eventually turn into a completely unmanageable junk drawer?
It absolutely can turn into a junk drawer if you lack discipline. But the author of the book argues there is a very intentional, highly beneficial philosophy behind leaving them in place initially.
Okay, what's the rule of thumb?
The rule of thumb advocated in the book is this: keep the main component exactly where you created it, firmly within the context of your actual living design.
Why?
Because it makes tweaking and iterating exponentially faster.
I can see the logic there. Like, if you're designing a complex dashboard widget, you want to see how the border radius on the widget component looks while it's sitting next to the actual sidebar and the actual header.
Exactly.
You don't want to constantly flip back and forth between a sterile blank components page and your real mockup just to check if a drop shadow is too heavy.
Context is everything during the exploration phase. You only move that main component when the context expands.
So what's the trigger to move it?
The specific trigger is reuse. The moment you realize, oh, I need to use this specific dashboard widget on the mobile view and the tablet view as well, that is when you take action. Once it's used in more than one place, you cut the main component, paste it onto a dedicated organized components page, and replace the hole you left in your original design with an instance.
That makes total sense. This strategy prevents you from over-engineering your file architecture before you actually know what the product requires.
Exactly. Don't optimize prematurely.
So, assuming we follow that strategy, eventually our product scales. We cut and paste hundreds of these master molds onto our dedicated components page.
Yep.
We have thousands of clones running around across dozens of screens. We rapidly approach a critical mass where finding what you need becomes a total nightmare.
It really does.
Searching through a disorganized assets panel is a guaranteed way to accidentally design the exact same calendar picker component twice, simply because you couldn't find the first one.
And duplicating work entirely defeats the purpose of implementing a system in the first place. This is where rigorous naming conventions become non-negotiable.
How does Figma handle the grouping?
Figma automatically groups your components in the Assets panel based on two things: their source and their path. The hierarchy it strictly follows is the file name, then the page name, then the frame it sits within, and finally, the actual component name.
That frame detail is something a lot of designers completely overlook. The physical frame that the component is drawn inside actually dictates its folder structure.
It does, and it's a powerful organizational lever if wielded correctly. If you draw a massive gray frame on your canvas and label it Form Controls, and then you arrange your checkbox, your toggle, and your radio button components physically inside that frame.
And Figma notices that.
Yeah, Figma's Assets panel will automatically generate a folder called Form Controls and nest them inside.
Oh, wow.
But the inverse is also true. If you accidentally leave a critical, globally used button component sitting inside a random frame labeled Draft Mockup v3,
oh no!
that button is going to be buried under a folder called Draft Mockup v3, and nobody in your team will ever find it.
That is a recipe for team-wide frustration. But relying purely on physical frames on a canvas can be fragile, right? Someone bumps a component outside the frame by 2 pixels, and suddenly it vanishes from the folder in the Assets panel.
Right, exactly. The more robust, bulletproof way to force organization is right in the text of the component's name itself. We have to talk about the power of the //
The slash naming convention.
The slash naming convention is the backbone of Figma organization. When Figma reads a / in a component's name, it interprets that slash as a command to create a folder directory.
Okay, give me an example. Let's say you're building out a massive suite of icons.
Right. You don't just name the individual components add, remove, and heart.
Right.
That will just dump them into a massive alphabetized list.
All right.
Instead, you name them icon add, icon remove, and icon heart.
Ah, I see.
When the Assets panel reads those names, it automatically spins up a master folder called icon and neatly files all 3 of those components inside it.
That's brilliant. But beyond just folder structures, the book highlights a massive pro tip for search optimization, right?
Yes, the SEO trick.
Most designers just rely on the component's literal name. But when you select a component, there's a dedicated description box waiting in the Properties panel.
And it's not just a place to leave developer handoff notes. That text box is fully indexed by Figma's internal search engine.
I cannot emphasize enough how much time this specific trick saves in a large organization. Let's take that icon heart component.
Okay.
If you have 50 designers in your company, they don't all think the same way. One designer might search the Assets panel for heart, another might search for love, a third might type favorite, and a fourth might look for like.
And if the component is only named heart, 3 out of 4 designers won't find it.
Exactly. They'll assume it doesn't exist and waste 20 minutes drawing a new one.
The solution is basically SEO search engine optimization for your design system. You go into that description box for the heart component and you just type heart, love, favorite, like, bookmark.
Now, no matter what vocabulary a colleague uses in the search bar, your component instantly surfaces.
It's a game changer.
Now, what if you are the unfortunate soul who inherits a massive legacy Figma file from a designer who didn't use slashes, didn't use descriptions, and just named things rectangle 4 and group 12?
Oh, that's painful.
You have to clean up hundreds of names. Doing that one by one is agonizing. But the bulk renaming tool in Figma is practically a magic wand for this, isn't it?
It is an incredibly powerful piece of software engineering tucked into a design tool. You can lasso 50 poorly named layers, hit Command R, and open the bulk rename dialog.
And what can you do in there?
You can append prefixes to all 50 simultaneously. You can add sequential numbering. But the real power is the match fields.
Let's say the previous designer grouped all the advertising banners under a prefix called banners. So you have banners hero, banners sidebar. But the marketing team just rebranded that department to promotions.
Right, you don't have to manually delete the word banners 50 times. You tell the bulk rename tool to find the exact string banners and replace it with promotions. It executes it instantly across the selection.
The book also points out that for true power users, the rename tool supports regular expressions, commonly known as regex.
Yes, right.
For those who might not have a computer science background, regex can sound intimidating, but it's basically a highly advanced search formula.
Very advanced.
Instead of just searching for a specific static word like banner, a regex formula allows you to search for abstract patterns.
Exactly. You could write a short string of characters that tells Figma. Find any component name that starts with a number, contains exactly 3 lowercase letters in the middle, and ends with the word button, and reformat all of them.
It's a steep learning curve, but it gives you absolute programmatic control over your file's architecture.
And, the entire point of this rigorous organization, the slashes, the SEO descriptions, the bulk renaming, is to eliminate friction during the actual design process. Because when you are in the flow state, designing a complex user journey, you're going to be swapping components constantly.
Swapping instances rapidly is what separates a junior pixel pusher from a senior systems architect. Imagine you're in a live design review meeting.
Always stressful.
The CEO is looking at your layout and says, "What if that solid primary button was just a hollow outline button instead? Let's see how that looks."
If you aren't using a component system, you have to awkwardly delete the fill color, add a stroke, change the text color, and realign everything while the whole room watches you sweat.
It's awful. But if you're using a properly organized system, you execute that change in 2 seconds. The book outlines 3 primary methods for swapping instances.
Right. The most visually intuitive method is the instance menu in the right-hand properties panel.
Because you utilize that slash naming convention, right? Figma understands the semantic relationship between your components.
Exactly. If you have button primary selected on your canvas, the instance menu doesn't just show you a random list of everything in your file. It automatically surfaces button outline and button danger right at the top because they share that button prefix.
That's the first method. The second method is a drag and drop replacement.
Yeah, you can open your assets panel on the left, find the new component you want, click, and drag it over to your canvas.
Yeah, and as you hover over the old instance you want to replace, you hold down a modifier key option on a Mac or Alt on Windows.
The component on the canvas will highlight, and when you release your mouse, the new component instantly snaps into the exact coordinates of the old one, absorbing its position.
And the third, and frankly the fastest method for power users, is the context menu.
Yep. You simply right-click the instance on the canvas, hover over Swap Instance in the dropdown, and select the replacement.
The caveat here is that the context menu only displays components that are immediately adjacent in the file architecture, so it only works well if your folder structures are impeccably organized.
It forces you to be organized.
But swapping a master mold for a different master mold is only half the battle. If every single clone we pull from the assets panel has to remain an identical pixel-perfect match to the original DNA, the system becomes too rigid to be useful.
Right.
If I have a master button component that says click here, I can't build an entire e-commerce site where every single button says click here. I need one to say add to cart, another to say proceed to checkout, and a third to say apply discount.
This is the delicate balancing act of systemic design. You need standardization, but you also need localized flexibility.
And that flexibility is achieved through overrides.
Overrides are huge. They allow you to mutate specific properties of an instance, bending it to fit the immediate context without severing the underlying umbilical cord that connects it to the main component.
We need to clearly establish the boundaries here, because understanding what Figma allows you to override versus what it locks down is crucial. What are the permitted mutations?
You were granted a surprisingly wide latitude. On any given instance, you can override the text content itself, changing "click here" to checkout.
That's the most common one.
Yeah. You can override the text styling, perhaps making one specific word inside a paragraph bold while the rest remains regular. You can completely swap out the fill colors, turning a blue background red. You can manipulate strokes, modifying borders.
What about effects?
You can pile on effects, like adding a heavy drop shadow to a specific card instance to make it pop over a modal. You can toggle the visibility of individual layers inside the instance, hiding an icon you don't need. And as we just discussed, you can swap out any nested components residing inside it.
Okay, so that's a lot of freedom. But the restrictions, the things you absolutely cannot change, are what maintain the structural integrity of the master mold. What is off limits?
You cannot fundamentally alter the architectural skeleton. You are forbidden from changing the size or the XY coordinate position of any nested layer inside that component.
So if there's a text box inside a card, I can't drag that text box 10 pixels to the left on the instance.
Nope. It won't let you. You also cannot reorder the layer hierarchy. What is on top stays on top. You cannot modify the responsive constraints, and you cannot touch the layout grids.
Why are those specific things locked down?
Well, because if you were allowed to drag layers around, change their order, and alter how they respond to resizing, the instance would completely lose its structural resemblance to the main component. It would be a totally new object.
Right.
If you need a layer to be in a fundamentally different position, that signifies you don't need an override. You need a distinctly different main component.
What I find truly elegant about Figma's engineering here is how it attempts to protect your overrides even when you change your mind about the underlying structure. Let's walk through a scenario.
Let's do it.
You have an instance of a standard text button. You've applied an override to change the text, say submit payment, and you've overridden the background color from gray to green. Then the product manager looks at it and says, actually, that shouldn't be a text button. It should be one of our icon buttons.
In older tools, swapping that component would wipe out all your localized work. The new icon button would revert to the default text and the default gray color. You'd have to retype the text and reapply the green color.
But Figma attempts to preserve your labor, right?
It does. When you swap the text button instance for the icon button component, Figma will intelligently try to map your submit payment text and your green color onto the new architecture.
It's a fantastic feature, but there is a massive structural caveat that listeners need to understand. Figma is smart, but it's not sentient.
No, it's just code.
It achieves this mapping by looking at the specific names of the layers inside the components. If the text layer inside your first button is named button label, and the text layer inside the new icon button is named text content,
Figma looks at them, decides they are two completely unrelated objects, and aggressively wipes out your override. Your submit payment text will vanish.
which brings us right back to the vital importance of strict, standardized naming conventions, not just for the components themselves, but for the individual layers nested inside them.
Exactly. Consistency has to penetrate all the way down to the base layer.
Now, let's look at the flow of data in the opposite direction. What if you make an override on a clone, for instance? You take an instance of a profile card, and you locally override the border radius to be sharply square instead of softly rounded.
Okay.
You look at it in context and realize, wow, this looks vastly better. In fact, every single profile card in the entire application should be square. Do you have to write down the specs, navigate back to your component library, find the main component, and manually recreate that sharp border?
You do not.
Ah!
Figma provides a two-way street.
Oh, thank goodness.
In the Properties panel for that modified instance, there is a subtle but incredibly powerful menu option called Push Overrides to Main Component.
And what does that do?
When you click that, Figma takes your local instance-level changes and beams them directly up to the master mold. The main component adopts the sharp square borders, and instantly that structural change cascades down, updating every other instance of that card across your entire project.
It allows you to organically evolve the design system directly from the specific mockups you are working on.
It's brilliant. But inevitably, you will hit a wall. You will encounter a scenario where you try to implement a design change but the component simply refuses to let you do it because the change violates the core architecture.
Like, you want to move an image 50 pixels to the right, but the component locks it in place.
Right, and that frustration often leads designers to the nuclear option.
Detaching the instance.
Detach it.
Detaching an instance severs the umbilical cord. You right-click, select Detach Instance, or hit Option-Command-B, and suddenly, the bounding box loses its magical purple color. It reverts to a standard, unlinked blue frame.
You now have total unrestricted freedom to move layers, delete things, and alter the architecture however you see fit.
But the author of the book makes a very pointed argument. You should feel a distinct twinge of guilt every single time you hit that detach shortcut.
You really should.
I love the terminology used here. The book borrows a concept directly from software engineering, the code smell.
A code smell is a brilliant diagnostic term.
What exactly does it mean?
It doesn't mean the code you just wrote is broken or that the app is going to crash. A code smell is a surface-level symptom that indicates a much deeper systemic rotting within the underlying architecture.
Oh, wow.
In the context of Figma, if you or your team find yourselves constantly detaching instances just to achieve the necessary layouts for your product, your design system is actively failing you.
It means the system is too rigid to reflect reality.
Exactly.
If every time a designer tries to use the article header component, they have to detach it to make the title fit, the problem isn't the designer. The problem is that the article header was architected poorly.
It is such a critical metric for systemic health that Figma actually built surveillance for it into their enterprise-level organization plan.
Surveillance? Really?
Yeah. Companies on those plans have access to design system analytics. A design systems manager can log in and see a dashboard showing exactly how many times specific instances have been detached across the entire company.
That is wild.
If the data reveals that the checkout form component has an 80% detach rate, the systems team knows immediately that they need to interview the designers, figure out why it's failing, and completely rebuild that component from the ground up.
The analytics are quite literally tattling on your bad architectural decisions.
They absolutely are.
However, we should clarify that there is one specific workflow scenario where detaching an instance is not a code smell, it is actually the explicitly recommended safe path.
Yes, that scenario is deprecation and deletion.
Let's set that up. Let's say you have a main component, an old navigation bar that is completely obsolete. You have removed it from all your active screens, and you want to delete the master mold from your library to keep things clean.
Okay.
If you simply select the main component and hit the delete key, what are the consequences?
Total systemic fragmentation. Any forgotten instance of that navigation bar sitting in an archive file or developer's reference file is suddenly orphaned. It has a broken link. It loses its connection to the system entirely.
To prevent that fragmentation, the safe deletion strategy requires a few extra steps. Before you delete the main component, you create one final instance of it right next to it on the canvas. Then you intentionally detach that single instance.
Right. And what you are left with is a raw, unlinked frame containing all the vector paths, text layers, and precise spacing of the original design.
It's like taking a high-resolution photograph of the mold before you smash it.
Exactly. Once you have that raw frame safely preserved, you can confidently delete the main component. The component is purged from your assets panel, keeping the library clean, but you retain the exact visual specifications in your file for historical reference.
And if, 6 months later, you discover an orphaned instance out in the wild and you desperately need to update it, Figma has a failsafe.
Oh, the restore button.
Yes, you can select that broken instance and click a button called Restore Main Component. Figma will analyze the residual DNA left inside the clone and magically reconstruct a brand new master mold from it, bringing it back from the dead.
It's an incredible safety net. But, if we accept the premise that detaching an instance during active design work is a code smell, that naturally begs the most important question of this entire deep dive.
Which is?
How do we build components that are inherently flexible enough that we never actually need to detach them?
To answer that, we have to move into the core thesis of the book, which involves taking hardcore software engineering principles and injecting them directly into our visual design canvas. The most vital of these is the principle of single responsibility.
The absolute bedrock of clean, maintainable programming.
Right. It states that every function class, or in our case, every visual component, should be responsible for executing one and strictly only one specific job.
I like to map this back to your earlier analogy of a mathematical function.
Oh, yeah.
If a component is the function, the overrides we apply, the text changes, the color swaps, are the variables or arguments we feed into that function. If you build a single component that attempts to simultaneously solve the background color, the typography scale, the complex grid layout, and the interactive hover states all at once, you have built a fragile monolith. When one tiny requirement changes, the whole monolith shatters.
The book illustrates this beautifully by deconstructing the complex navigation header of a real-world product, the Postmark app.
Oh, this is a great example.
If a junior designer looks at a dense web application header, they see a logo on the far left, a row of 5 navigation links in the middle, a search bar on the right, and maybe a user avatar dropdown.
And the instinct is to draw a massive rectangle, place all those elements inside it, space them out perfectly, highlight the whole thing, and turn it into one giant component called global header.
And that giant component will be a nightmare to maintain. To achieve true flexibility, you must architect the header as a nested hierarchy, where every layer of the nest has a single responsibility.
Let's walk the listener through exactly how to build that nested hierarchy from the outside in.
Okay, we start with the master container. We create a main component and call it simply header. What is the singular job of this header component?
The header component is completely ignorant of typography or colors. Its sole responsibility is macro layout.
Macro layout, okay.
It dictates the padding between the extreme left side of the screen where the logo sits, the center area where the navigation sits, and the extreme right side where the avatar sits. It manages the white space between those 3 major structural blocks. That is its only job.
Okay, so we step down one level deeper. We look inside the middle block, the navigation area. We create a nested component specifically for this called nav block. What is its single responsibility?
The nav block component doesn't care about the logo on the left, and it doesn't care what the actual text of the link says. Its single responsibility is managing the micro layout.
Which means?
Specifically, the horizontal gap spacing between a row of individual link items. It ensures that every link is exactly 24 pixels apart.
We step down one final level into the atomic unit, the individual link itself. Let's call this component the subnav link default. It consists of a tiny icon next to a text label. What is its responsibility?
The subnav link component is entirely focused on the relationship between that small icon and that specific word. It dictates the 8-pixel gap between them, and it establishes the baseline alignment, so the icon doesn't look vertically crooked next to the text.
Right.
It doesn't care about the other links in the row, and it certainly doesn't care about the global header padding.
So why go through the effort of building this intricate Russian nesting doll architecture? Because the flexibility it unlocks is staggering.
It really is.
Let's say the marketing team decides the font size of the navigation links needs to be 2 points larger to improve accessibility.
If you had built a monolithic component, changing that font size might cause the text to crash into the icons or push the whole navigation block off center, requiring you to manually readjust the entire header.
But with single responsibility architecture,
You open the tiny subnav link component. You increase the font size. That component automatically widens to accommodate the larger text. Because the parent nav block component's only job is to maintain a 24-pixel gap, it automatically pushes the neighboring links outward to inspect the new width.
wow.
And because the master header component's only job is macro layout, it seamlessly recenters the entire expanded navigation block. The change cascades upward flawlessly without breaking a single layout rule.
It feels like an immense amount of abstract upfront labor to build these tiny pieces, but the moment your product scales beyond a single landing page, this architecture pays massive compounding dividends. You stop fighting your files,
Exactly.
which flows perfectly into the next major engineering concept we need to steal: inheritance.
Inheritance is about establishing a source of truth for the baseline structure of an object, and having variations of that object inherit that truth, so you don't have to manually sync updates across multiple files.
The classic trap here involves interactive states. Let's stick with our navigation link. We have a default state. It's just a gray icon sitting next to gray text.
Right.
But interfaces are interactive. When a user clicks that link, it needs to visually communicate that it is active. We need an active state. Let's say the design spec calls for the text to turn vibrant blue, the icon to turn vibrant blue, and a thick blue underline to appear beneath them.
Historically, the workflow for this was purely additive duplication. A designer would take the default component, duplicate it entirely, change the hex codes to blue, draw a rectangle for the underline, and convert that new object into a completely independent main component called active.
And what is the long-term danger of having those two distinct parallel components?
The danger is divergence. 3 weeks later, a product manager reviews the site and decides that the 8-pixel gap between the icon and the text feels too tight. It needs to be 12 pixels.
Okay, so the designer goes in, finds the default component, updates the spacing to 12 pixels, and publishes the change.
But because the active component is a completely separate entity, it doesn't receive that update. It still has an 8-pixel gap.
And suddenly your interface feels glitchy. When the user clicks the link, not only does it turn blue, but the text physically jumps 4 pixels to the left because the spacing parameters are out of sync between the states. Your system is fraying at the edges.
Exactly.
So how does the concept of inheritance elegantly eliminate this risk?
You utilize nesting to force the variations to inherit from the baseline. Instead of building the active state from scratch, you begin by placing an instance of the default component onto your canvas. This instance is linked to the baseline architecture.
Okay, so I have my gray clone sitting on the canvas.
Now you use your standard overrides. You select the text inside the instance and override the color to blue. You override the icon color to blue. You draw your blue underlined rectangle beneath the instance.
Simple enough.
And then this is the stroke of architectural genius. You select that entire modified cluster, hit Option-Command-K, and wrap it into a new main component, naming it active.
Wow, so the active component literally has the default component beating inside its chest like a heart.
Precisely. It inherits the structural DNA. Now observe how we are combining principles. The outer active component has a single responsibility. It only cares about applying the blue interactive styling.
And the inner nested default component has a single responsibility. It manages the structural layout and spacing.
Yes. If the product manager demands that 12-pixel gap, you update the spacing once in the default component. Because the active state is just a wrapper around an instance of that default, it automatically shifts to match. They can never fall out of sync.
That is the definition of structural elegance. It removes the burden of human memory from system maintenance.
It really does.
But interactive states like hover and active are relatively simple. Sometimes the sheer volume of structural permutations an object requires is overwhelming. Changing colors is easy, changing massive layout blocks is hard. This brings us to the concept of visibility overrides.
Visibility overrides are the mechanic we use to manage extreme structural variations without cluttering our library with hundreds of slightly different master components.
The book uses the anatomy of a standard social media post, specifically, a tweet and a timeline, as the prime example of this complexity. If you break down a single tweet, the potential combinations are staggering.
At its base, it has an avatar, a username, and some text.
But consider the attachments. It might have a small thumbnail link attached to the bottom, or it might have a massive edge-to-edge embedded image, or a playable video block, or it could be a quote tweet embedding another entire tweet inside itself.
It might have a tiny badge at the top saying Elon liked this,
Oh.
or a badge at the bottom flagging it as promoted content.
If you attempted to construct a separate, bespoke main component for every possible permutation of those elements, a component for text plus video, a component for text plus image plus promoted, the math scales aggressively. You would have to manage over 50 distinct tweet components.
Your library would be unnavigable.
So what is the architectural solution that software engineers use for this?
You build one single omnipotent God component. You create one massive main component that contains absolutely every possible module simultaneously.
Everything at once.
Everything. You stack the liked badge, the text block, the embedded image, the video player, the quote block, and the promoted badge, all on top of each other within the same frame.
But if you just drop an instance of that God component onto a mockup, it looks like a catastrophic mess of overlapping elements. How do you control the chaos?
The linchpin of this entire strategy is Figma's auto layout feature. Auto layout is a layout engine that forces layers to stack dynamically, behaving more like HTML structural blocks than free-floating graphic layers. If you wrap all those tweet modules in an auto layout frame, they stack neatly on top of each other.
Okay, so they are neatly stacked, but it's still a massively tall, absurd-looking tweet with a video and an image and a quote block all at once.
True. But here is the magic trick. You take an instance of that God component, you look at your specific mockup and decide, I just need a standard text-only tweet here.
Okay.
You go into the Layers panel for that instance, find the video player layer, and you click the little eyeball icon to toggle its visibility to off. You do the same for the image, the quote block, and the badges.
And because of the auto layout engine, the component doesn't just leave massive empty white gaps where the video used to be, right?
Exactly. It treats the hidden layers as if they have been completely deleted from the document's flow. The text block seamlessly slides up, the bounding box collapses tightly around it, and it magically snaps into a perfect, compact, text-only tweet.
It's an incredibly robust system. You use that single God component, and purely by toggling layer visibility on the instances, you can generate dozens of unique structural layouts.
And the maintenance benefit is immense. If Twitter undergoes a rebrand and decides the user avatar needs to be moved from the left side to the top right, you execute that move exactly once inside the God component. Every single variation of the tweet across your entire system updates perfectly and instantly.
It's brilliantly efficient. However, as your design system matures, you run into a new friction point.
Oh, there's always a new friction point.
Even if we are using clever tricks like visibility overrides and strict /naming conventions like button primary hover and button secondary disabled, browsing through a massive nested tree of /names in the assets panel becomes incredibly tedious.
Searching for the exact state of a button feels like hunting through a filing cabinet.
We need an interface that maps more cleanly to how developers actually write their code. And that introduces us to section 4 of our deep dive, variants.
The introduction of variants was arguably one of the most significant architectural shifts in Figma's history. It allows you to take all those loosely grouped components that share a prefix, like all your buttons, and bind them together into a single cohesive entity called a component set.
To understand why this is so valuable, we have to look at the developer's side of the screen. In modern front-end code bases, a developer does not maintain 18 different files for 18 different button states.
They don't write code that explicitly calls a component named button primary large hover. That is wildly inefficient.
Instead, they build one master button component, and they control its behavior by passing properties, commonly referred to as props, into it.
Right. They write a line of code that says, render a button, set the type prop to primary, set the size prop to large, set the state prop to hover. The code dynamically renders the correct visual output based on those props.
Variants are Figma's mechanism for giving designers that exact same property-based interface. You can set up one-dimensional variants, which are simple. Imagine a toggle switch. It just has a state property with two values, on and off.
But the real power is multi-dimensional variants. Let's expand on that button example. Imagine a comprehensive system where a button has a type property with 3 values: primary, secondary, danger.
Okay.
It has a size property with 3 values, small, medium, large, and it has a state property with 2 values, default, hover.
3 types multiplied by 3 sizes multiplied by 2 states.
Yep.
That equals 18 distinct visual components. Without variants, your assets panel is cluttered with a list of 18 separate items you have to scroll through.
But once you bind them into a component set using variants, the assets panel cleans up instantly. It collapses all 18 items into one single draggable item, simply named button.
And when you drag that button onto your canvas, the properties panel on the right side of your screen transforms into a sleek, dedicated configuration dashboard.
It literally generates drop-down menus for you.
You don't have to search for the right component anymore. You just drag out a button, click the type drop-down and select secondary, click the size drop-down and select large, and the button instantly morphs on the canvas to match those specs.
It is a massive workflow acceleration. Now, you might assume that configuring this complex mapping between 18 components and 3 different property dropdowns would be a technical nightmare requiring manual data entry.
It sounds like it should be.
But Figma engineered the setup process to be almost entirely automated, provided you followed the rules earlier.
This is where that strict /naming convention pays off exponentially. Let's walk through the setup. You have your 18 separate button components on the canvas. Because you're disciplined, you name them meticulously. One is named exactly button primary large default. Another is named button secondary small hover.
If you highlight all 18 of those properly named components on your canvas, a button appears in the right sidebar labeled Combine as Variants. The moment you click that button, Figma executes a brilliant parsing algorithm.
It reads the slashes.
It reads the slashes. It looks at the very first word before the first slash button and establishes that as the master name of the entire component set.
Okay, what about the rest?
Then it looks at the string of words after the first slash primary and secondary and realizes, these are alternating values. It automatically spins up a new property dropdown and populates it with primary and secondary as the selectable choices.
It continues down the chain, parsing the sizes into a second property and the states into a third. The mapping of the values is fully automated.
The only minor manual cleanup required is that Figma isn't quite smart enough to know what the abstract categories represent. It just labels the new drop-down menus generically as Property 1, Property 2, and Property 3.
So you simply click into the variant settings and rename Property 1 to type, Property 2 to size, and you're finished. Your UI configurator is fully operational.
And while we are talking about UI configurators, the book points out a phenomenal subtle feature regarding how you name those specific values. You can use binary logic to dramatically improve the user experience of the Properties panel for your fellow designers.
This is one of those delightful details that separates a good design system from a great one. Let's say you have a card component. Sometimes the card requires an icon at the top and sometimes it doesn't.
Right. A standard approach would be to create a property named icon and name the two variant values with icon and without icon. That generates a standard drop-down menu.
It works, but it requires 2 clicks to change, opening the drop-down and selecting the option.
If, instead, you name the property has icon, and you set the values to literally just the word true and the word false, or the words on and off, or yes and no, Figma's engine recognizes that you are using binary logic.
What does it do?
It intercepts the UI rendering, removes the clunky drop-down menu entirely, and replaces it with a sleek native toggle switch.
You literally just get a switch in the panel that you can flick on or off to make the icon appear or disappear. It's incredibly satisfying and shaves a microsecond of friction off every interaction.
Now, managing all these advanced components involves some operational housekeeping. The book covers strategies for creating components in bulk, which is critical when migrating systems.
Right. If you purchase a premium icon set and import a folder of 150 raw SVG vector icons onto your canvas, you do not want to manually select each one and hit Option-Command-K 150 times.
That would be agonizing. The bulk solution is hidden in plain sight. You select all 150 icons simultaneously. In the top toolbar, right next to the standard diamond Create Component button, there's a tiny drop-down arrow.
You click that arrow, select Create Multiple Components, and boom. In a fraction of a second, you generate 150 distinct main components, ready to be organized.
But the operational lifecycle doesn't end at creation. We have to discuss the other end of the spectrum when components die. We need to talk about deprecation.
Because you cannot simply hit the delete key on a core component that is actively embedded in 400 different screens across a massive enterprise product.
This is where design architecture bleeds into product management. Sometimes a component is fundamentally flawed. The original architecture was so poorly conceived that visibility overrides and variants can't save it. It needs to be burned to the ground and rebuilt.
If you just drastically redesign the old component in place, you risk breaking the layout of hundreds of historical mockups that relied on its old dimensions.
To prevent that chaos, you must deprecate the old component gracefully. You leave it alive, but you actively discourage anyone from using it moving forward.
The deprecation process outlined in the book is fascinating. It's like setting up hazard tape around a construction zone. Step 1. You create a brand new page within your master Figma file. You literally name the page using the stop sign emoji. Oh, deprecated.
You cut and paste the old flawed main component onto that page. This physically removes it from the standard component library pages, making it harder for a designer to casually stumble across.
But that isn't enough to stop someone from using it if they already have an instance of it sitting on their clipboard. Step 2 is a brilliant visual deterrent.
You take that old main component and you draw a massive, bright red, semi-transparent rectangle over the absolute entirety of it.
The mechanism here is ruthless but necessary. Because instances faithfully inherit the visual properties of the master mold, the absolute second you drop that ugly red box over the main component.
That red box instantly materializes on every single instance of that component across the entire company's ecosystem.
Any designer who opens a file and sees a massive red box obscuring their layout immediately knows, okay, I'm using an illegal component, I need to update this.
It is the ultimate, unavoidable visual warning. But you can't just leave a company's files covered in red boxes. There is manual labor required to complete the migration.
Once the new, properly architected component is built, the systems team must execute a controlled migration. The book recommends leveraging community plugins, specifically one called Instance Finder, to systematically hunt down every single red-boxed instance across the company's hundreds of files.
Once located, the team manually swaps the old instance for the new one, verifying that the layout doesn't shatter in the process. It is tedious, unglamorous work, but in a large-scale organization, A controlled burn is the only safe way to migrate infrastructure.
So, up to this point, we have spent an immense amount of time dissecting components and variants. These tools dictate the structural architecture, the nested hierarchy, and the interactive functionality of our designs. They are the blueprints.
But what about the actual aesthetics? The color palette, the typography scales, the depth of the drop shadows? A blueprint doesn't dictate what color the walls are painted.
That brings us to Section 5, Styles.
If components are the structural blueprint, styles are the buckets of paint you buy at the hardware store. They are distinct, globally reusable properties that govern the visual appearance of your interface, completely independent of the structural framework. You can change the paint color without moving the walls.
Figma categorizes these aesthetic properties into 4 primary buckets: color styles, text styles, effect styles, which handle your drop shadows and blur effects, and layout grid styles.
The mechanics of creating them are incredibly straightforward. You draw a rectangle, you manually mix a specific shade of teal in the color picker, and you decide, this is our new brand color.
In the Properties panel next to the Fill section, there is a small icon featuring 4 dots and a square. You click that, hit the plus button, and you have minted a global color style.
And critically, you can organize them using the exact same /convention we used for components. Naming a text style headers H1 will neatly nest it inside a headers folder in your style directory.
But while creating them is easy, the philosophy behind how you name your color styles is one of the most hotly debated topics in the design systems community.
Oh, absolutely. The natural instinct for a junior designer is to name a style based on its literal visual description. They mix a beautiful shade of blue, so they name the style blue.
Which on the surface seems perfectly logical. It is objectively blue.
It is logical in the short term, but it is an absolute semantic nightmare in the long term. The author of the book strongly advocates against descriptive naming and instead champions naming colors by their role or their function within the interface.
To illustrate why, we need to look at the lifespan of a startup. Let's say your startup's primary brand color is that beautiful blue. You name the style blue and apply it to every primary button, every active navigation link, and every header across your entire app.
2 years later, the marketing department executes a massive rebrand. The company's new primary color is a vibrant purple.
The global update mechanic is easy. You open the blue style, you change the hex code to purple, and instantly every button and header in the app turns purple. The design is updated.
But the semantic architecture is completely broken. You now have a global style fundamentally labeled blue that actively paints everything on the screen purple. It will confuse every new designer and developer hired from that day forward.
However, if you had utilized functional naming from the start, if you had named that initial blue style primary brand or accent, the name flawlessly survives the rebrand. Accent was blue yesterday. Today, accent is purple. The underlying code makes sense.
It's a compelling argument for abstraction.
I do want to push back on this concept, though, because while role-based naming works flawlessly for small marketing sites, does it actually scale to complex enterprise software?
That's the counter-argument, yeah.
If I just use accent, background, warning, and success, that covers maybe 10 functional colors. What happens when your application requires highly technical data visualization dashboards that demand 80 different distinct shades of gray, blue, and green to delineate complex UI borders and chart metrics?
Right.
Naming a color accent 27 or secondary background subdued becomes meaningless word salad to a developer.
That is a highly valid critique, and it's a tension the book addresses head-on. Abstract, role-based naming works brilliantly for text styles. Calling something H1 or body is universal. But for massive, high-density color palettes, roles break down.
So what's the alternative?
Eugene Fedorenko, a contributor to the book and designer for the Postmark app, offers the counter-argument. For their extensive enterprise system, they abandon abstract roles and prioritize strict, scalable precision. They implement a numerical scaling system.
For those familiar with front-end development, this is exactly the paradigm popularized by the CSS framework Tailwind.
Exactly. Tailwind CSS revolutionized how developers handle color by moving away from abstract names and using a predictable numerical scale from 50, which is the lightest, to 900, which is the darkest. The Postmark team adopted this directly into their Figma styles. They have Mint 100, Mint 300, Mint 500, all the way to Mint 900.
It strips away the pretense of telling you where to use the color. Mint 500 doesn't dictate that it must be used on a button.
But what it provides is a rigorous, highly searchable dictionary of the exact spectrum available to the team. If a border looks too light at gray 200, you don't have to guess what the next shade is called, you just instinctively bump it up to gray 300.
The takeaway here is that there is no universal right answer. You must choose the naming convention that matches the complexity of the product you are building.
Regardless of how you name them, the core mechanic of styles is their global linkage. If you tweak the hex code of Mint 500 to be slightly more yellow, every single vector shape in the document utilizing that style updates immediately.
But there are frequent workflow scenarios where a designer wants to utilize a color from the system, but explicitly does not want it tethered to that global linkage.
This is where the detach mechanic resurfaces. If you apply a global style to a rectangle, you can look at the Properties panel and click the broken link icon next to the style's name.
This performs a very specific action. It locks in the raw hex code of the color on that shape, but it severs the umbilical cord to the global style directory. If Mint 500 updates tomorrow, your detached rectangle stays exactly as it was.
It turns a dynamic property into a static property. But there is a much more elegant, subtle UI trick mentioned in the book for sampling colors without ever establishing that global link in the first place.
I love this trick because I think 90% of Figma users completely miss it. Imagine you are quickly experimenting with a new temporary banner design. You want to see how it looks using the company's brand colors, but you don't want to formally link the banner's layers to the global styles because it's just a messy scratchpad file.
If you select a shape and open the standard color picker tool to manually mix a color, you will see a grid of swatches labeled document colors. These are just raw hex codes recently used in your file. But immediately adjacent to that, there's a drop-down section titled Local Colors.
This Local Colors section displays all of your formerly saved color styles, your Mint 500s, and your accents rendered as small, clickable swatches.
The mechanism here is crucial. If you click a swatch from the Local Colors menu inside the color picker, Figma grabs the raw hex value from that style and applies it to your shape as a static fill.
It does not apply the linked style itself.
Right. It acts as a brilliantly fast sampling tool, allowing you to borrow from the system's aesthetic palette without committing your scratchpad experiments to the system's global architecture.
It is all about intent. Are you building a permanent fixture that needs to be globally linked, or are you just borrowing paint for a temporary sketch?
Exactly.
Which brings us to the ultimate crucible of design systems: scaling operations. Up to this point, through sections 1 to 5, every component, variant, and style we have discussed has existed safely within the confines of a single Figma file.
And if you are a solo freelancer working on a single landing page, a single file is all you will ever need. But Section 6 addresses what happens when a startup matures into a corporation.
You don't just have one product anymore. You have a marketing website file, an iOS app file, an Android app file, an internal customer service dashboard file, and a dozen Scratchpad files.
You have 20 different files, and every single one of them needs to use the exact same primary button component and the exact same Mint 500 color style.
If you just copy and paste the components between files, you break the links, and you end up maintaining 20 distinct diverging systems. You need a single source of truth. Enter the team library.
The team library is Figma's infrastructure for global distribution. The architecture works like this. You dedicate one specific Figma file to act as the master registry. You might title it Core Design System. You build all your main components and styles strictly within this file. Then you publish that file to Figma's cloud as a library. Let's drop a quick technical note here regarding pricing tiers as it dictates how you can use this. Figma allows anyone, even users on the free starter plan, to publish color and text styles to a team library. However, the ability to publish interactive components to a library requires upgrading to a paid professional or organization plan. Assuming your team has the infrastructure, the publishing mechanism is straightforward. You open your master registry file, open the Assets panel, and click the small book icon at the top. This opens the library's modal and you hit Publish.
Once published, any designer working in any other file within your organization can open their local libraries menu, toggle the switch next to Core Design System to on, and miraculously, every component and style from the master registry floods into their local assets panel, ready to be dragged onto their canvas.
It connects the entire company.
Yeah.
But it also presents an immediate curation problem.
What if your master registry file contains experimental scratchpads? Or what if you built a hyper-specific, massive illustration component that was only meant to be used for one specific onboarding screen?
You absolutely do not want to publish that to the global team library, because it will clutter the search results for every designer trying to find basic buttons.
You need a mechanism to explicitly exclude certain assets from the global push. Figma offers a manual UI approach. You can right-click any component in the Publish dialog box and select Remove from Library, marking it as private. But that requires remembering to do it every time you publish.
The professional, bulletproof way to handle this relies on a brilliant syntax trick borrowed directly from software engineering.
This is one of my absolute favorite technical crossovers.
If you prefix the name of any component or any style with either an underscore or a period, for example, naming a component Scratchpad Grid, or Experimental Button Figma's publishing engine automatically flags that asset as private and forcibly hides it from the team library distribution process.
For the non-engineers listening, this is not an arbitrary choice by Figma. This is deep-rooted computer science logic. In Unix-based operating systems, like the Mac OS running on your MacBook, if you start a file name with a dot, the operating system registers it as a hidden file, keeping it out of the standard Finder view.
In programming languages like Python or JavaScript, developers frequently start the name of a function with an underscore to denote that it is a private function, meant to be used only within that specific script and never exposed to external software. Figma respects and implements that exact same semantic logic.
It allows you to build incredibly messy, complex helper components behind the scenes without ever polluting the pristine public library your team interacts with.
So let's flip to the consumer side of this dynamic. I am a junior designer, and I open up the marketing website file. I toggle on the core design system library. My assets panel is suddenly populated with hundreds of tools. How does Figma organize this influx of data so I don't lose my mind?
The Assets panel implements a strict 3-tier categorical breakdown to provide immediate context on where an object is coming from. The top tier is labeled Local Components. These are components that were physically created within the specific file you currently have open.
And if you utilize that underscore trick we just discussed, Figma creates a subfolder right there called Private to this file to neatly quarantine your hidden assets.
Exactly. The second tier down is a dynamic category called Used in this file. This is a massive workflow accelerator.
If your company's global library contains 5,000 components, but your specific marketing file only heavily utilizes the hero banner and the email sign-up form, Figma algorithmically surfaces those specific external components into this quick access tier. You don't have to go digging through the massive global directory every time you need them.
And the final, bottom tier, is Enabled Libraries, which provides the exhaustive, searchable directory tree of every component available from the global systems you have linked.
Okay, so we have established the connection, the files are linked. Now we must address the most critical workflow mechanism of the entire deep dive.
Let's revisit the disaster scenario I painted in the opening hook of the show.
The shattering layout.
Exactly. The lead design architect opens the core design system master file. They decide the primary button shouldn't be a sharp rectangle anymore. It should be a heavily rounded pill shape. They make the change to the master mold and they hit Publish.
In almost any other modern collaborative software, like a synced Dropbox folder or a live Google Doc, that change is pushed immediately and automatically to every connected user. If someone changes a paragraph in Google Docs, it changes on your screen half a second later.
Why doesn't Figma operate like Dropbox? Why doesn't it just automatically force that rounded button onto my active canvas? Wouldn't automatic syncing be faster?
Faster, yes. But if we connect this to the bigger picture of structural dependencies, automatic syncing is a recipe for absolute systemic collapse. We have to differentiate between content and architecture. If someone fixes a typo in a Google Doc, it doesn't break the document. But if you are in the middle of a high-pressure client presentation, and Figma automatically forces a button-shaped change that expands the width of the button by 20 pixels, your perfectly aligned grid shatters. Text wraps incorrectly. The design breaks right in front of the client's eyes. You would lose total trust in the tool.
It removes the designer's agency over their own file.
Precisely. And this is why Figma, once again, looks to the software engineering world for the solution. Engineers do not use Dropbox to manage collaborative code bases because automatic syncing would constantly break the software. They use Git.
Git is a version control system that requires changes to be manually proposed, manually reviewed, and manually pulled into the local environment.
Figma mimics the Git workflow. The update process must be manual to ensure absolute accountability and layout stability.
Let's walk through the exact mechanics of how that manual pull process works in Figma.
When the lead architect modifies that button and hits Publish in the master file, they're presented with a mandatory text box asking for a commit message, a brief description of what was altered. They type, updated primary button border radius to pill shape. They hit Submit.
On your end, in your marketing file, your layout does not change. Nothing breaks. Instead, a small, unobtrusive notification dot appears in the bottom right corner of your interface next to the assets icon.
It sits there politely waiting for you.
Exactly. It says component updates available. You can ignore it for hours if you are in the middle of a critical task. When you are ready, you click the dot and you hit review.
Figma opens a split-screen diff viewer. It shows you the exact component that changed. It shows you what the old button looks like, what the new button looks like, and it displays the architect's message explaining why it changed.
You review the impact, and then, and only then, do you explicitly click Update All to manually pull those architectural changes into your local file.
You are always the final gatekeeper of your own canvas. No surprises.
But managing this interconnected web of global libraries gets incredibly thorny when a company reorganizes and files need to be moved or dismantled. What is the protocol if an entire master library needs to be retired? What happens if I unpublish a file?
Unpublishing is relatively safe. You open the library window in the master file and hit Unpublish. It immediately removes the library from the global directory. No new files can link to it. But Figma is smart enough not to destroy existing work. Any file that had already utilized components from that library retains them. The legacy instances remain perfectly intact on their canvases. The only difference is that the link is permanently severed. Those instances will never receive another update from the master mold.
Moving individual assets between files, however. This is where the elegance of Figma's architecture breaks down and exposes some severe friction. Let's say a designer creates a brilliant new data table style locally in their Scratchpad file, and the team decides it is so good it needs to be promoted to the global core design system library. Moving a style is a shockingly backward, unintuitive process.
It's arguably one of the clunkiest workflows in the application. You cannot just copy the style from the Scratchpad and paste it into the core library. To execute the move, you have to open the destination file, the core library. From there, you enable access to the local Scratchpad file. You draw a random temporary rectangle on the canvas. You apply the local data table style to that rectangle. Then you click the Edit Style icon, and buried deep within a secondary context menu, there's an option titled Move Style Definition into this file.
It feels like performing a magic trick just to bypass the system's restrictions.
It yanks the master definition of the style across the file boundary, rehoming it in the core library without breaking the connections of any legacy objects that were already using it. It functionally works, but it defies all standard UI logic.
And if moving a style is clunky, moving a component is the hard, brutal truth of Figma system architecture. You simply cannot move a main component between files. It is an impossible action.
The foundational rule of Figma is that the master mold's DNA is permanently, inextricably locked to the file in which it was born.
So if a team decides to split their massive core design system file into two separate files, one for web components and one for mobile components, how do they physically migrate the mobile main components over to the new file?
It requires a heavy, destructive migration process. You copy the main component from file A and you paste it into file B. But remember the rules we discussed in section 1. Copying a main component does not duplicate the mold. It spawns a clone. So when you paste it into file B, it arrives as a linked instance. To complete the migration, you must select that instance, hit the detach shortcut to sever its tie to file A, hit Option-Command-K to reforge it into a brand new main component native to file B, and publish the new library.
And the nightmare doesn't end there.
No. Because you just create a fundamentally new component, every single screen across your company that used the old component from file A is now linked to a dead end. You have to boot up the Instance Finder plugin, hunt down every single historical usage of the old component across every file in the organization, and manually swap them over to the new component from file B.
It is a grueling manual data migration project, which leads us perfectly into our final section, Section 7, Version History. Because when you are asking human beings to manually execute complex component migrations, manage nested single responsibility architectures, and govern global system updates, human error is inevitable. Someone is going to accidentally delete the wrong master mold. Someone is going to break a vital inheritance chain. When the architecture collapses, we need a time machine. We need a safety net.
Figma provides that safety net through a remarkably robust version history system. By default, it operates silently in the background as an autosave mechanism. Figma monitors your activity, and roughly every 30 minutes of idle time, or when you close the tab, it compiles a snapshot of the file's current state and logs it to the timeline.
Autosaves are fantastic if your laptop runs out of battery and you just need to recover the last 20 minutes of layout work. But relying purely on automated 30-minute snapshots to manage the integrity of a global, enterprise-level design system is reckless. If a critical bug is introduced, you don't want to hunt through 50 vaguely time-stamped autosaves trying to find the exact minute the file was stable. You can, and absolutely must, manually save and explicitly name your architectural versions.
This requires discipline. The shortcut on a Mac is Command-Option-S. Executing that command overrides the autosave cycle and forces Figma to log a permanent version to the history timeline right at that exact second. It presents you with a dialog box demanding two inputs, a title and a description of what you just accomplished.
But let's be honest about human nature. The book includes a brilliant reference to a classic XKCD comic that perfectly illustrates the psychological reality of version control.
The Git Commit comic. It highlights how, over the life cycle of a long, grueling project, a developer's dedication to writing clear, helpful commit messages degrades rapidly. On Monday, at the start of the sprint, the developer saves their work and writes a beautiful, detailed message. Created main loop, implemented timing control, fixed memory leak. By Wednesday, the message devolves to just miss bug fixes. By Friday at 2 a.m., exhausted and frustrated, the commit message is literally just the word, "Hey Shans," or random keyboard smashing.
We have all absolutely been there. You just want to save the file and go to sleep. But when you are architecting a shared system for an entire company, keyboard smashing is a dereliction of duty. 6 months from now, a new designer is going to look at a complex God component and wonder why a specific auto layout hack was used. If they check the version history and the description just says updated stuff, the historical context is lost forever. To solve this, we must enforce developer best practices for our design history. The book outlines 4 specific rules for writing commit messages.
Rule number 1 is structural. The high-level summary belongs in the title field, and the granular technical explanation belongs in the description box. Do not cram paragraphs into the title.
Rule number 2 is grammatical, but crucial. Write your titles using the imperative mood. Give a command to the system.
Exactly. You write fix typography scale on checkout button. You do not write fix typo or fixes typo. Writing in the imperative mood ensures that every single version title in the timeline reads clearly as an action that is being applied to the file. It keeps the history action-oriented and easily scannable.
Rule number 3 is about bridging the gap with project management. If your engineering and product teams use an issue tracking software like Jira, Asana, or Linear to manage tasks, you must include the specific ticket reference number directly in the Figma version description.
If the description reads, implement new dark mode palette, resolves Jira ticket #4092, you have instantly linked the visual design file to the broader product management ecosystem. A developer can click that version, see the Jira ticket, and immediately read all the background context, business logic, and stakeholder approvals that led to that specific design change.
And rule number 4, which sounds incredibly pedantic but matters immensely at scale, use proper capitalization and punctuation. Writing clear, professional sentences communicates to the rest of the team that you are treating the design system with care and rigor. It sets a standard. Now let's explore the disaster recovery process. The file is ruined. You open up the version history panel on the right side of the screen. You click back through time, viewing the ghostly past states of the canvas, and you finally locate the exact version saved on Tuesday at 4 p.m., right before the architecture was corrupted. You right-click that version. You're presented with 2 primary recovery options: restore this version or duplicate. Understanding the mechanical difference between these 2 actions is vital.
Let's tackle restore this version first. The terminology can be slightly misleading because it implies you are wiping out the present and traveling back in time. That is not what happens. Restoring a version is a strictly non-destructive action.
So it doesn't erase the terrible mistakes you made on Wednesday and Thursday.
It does not. Figma preserves your mistakes. When you click Restore, Figma takes the pristine state of the file from Tuesday, copies it, and pastes it at the absolute top of the timeline, making it the new present state. It doesn't delete Wednesday and Thursday from the log, it simply paves over them. The timeline of your failure is permanently preserved for auditing purposes, but the active canvas is repaired.
Paving over is the perfect way to visualize it. You just lay fresh asphalt over the potholes. Now, how does duplicating differ?
Duplicating is a branching mechanism. If you duplicate an old version from Tuesday, Figma leaves your current, corrupted main file completely untouched. Instead, it generates a brand new, parallel Figma file on your dashboard containing the design exactly as it was on Tuesday.
Why would you choose to duplicate instead of restore?
Duplication is the ideal tool for exploring alternative realities. Imagine you had a fork in the road on Tuesday. You pursued design concept A for 3 days and realized on Friday that it was a dead end. You don't necessarily want to pave over all the hard work you did on concept A because there might be some useful assets in there. You duplicate the Tuesday version to create a clean slate, and you use that parallel file to start exploring design concept B without cluttering your main file.
The critical caveat to duplicating, though, is that the new parallel file is stripped bare of metadata. It loses the entire chronological comment history of the original file, and it resets all sharing permissions. It is truly a blank slate.
Okay, we have covered a staggering amount of technical ground today. To synthesize this journey, we have definitively established that modern interface design is no longer about drawing static pictures or pushing isolated pixels around the canvas. It is fundamentally a discipline of systems architecture.
We are building living, interconnected ecosystems fueled by reusable DNA.
And to tame that ecosystem, you must treat your Figma file with the exact same rigor that a software engineer treats a codebase. By utilizing components with precise overrides, structuring them logically, using the principle of single responsibility and inheritance, deploying variants to mirror developer properties, separating the structural blueprint from the aesthetic paint using styles, and governing the entire massive network through team libraries and disciplined version control. You eliminate the friction of scaling. You save yourself massive amounts of time, and you end the frustration of solving the exact same layout problems over and over again.
You establish a shared technical language that allows design and development to scale in perfect synchronization.
Once again, all of this foundational knowledge and so much more detail comes from the phenomenal book, Designing in Figma, a masterclass in modern interface design. It is an absolute must-read if you want to elevate your career from designer to systems architect. And if you made it this far, please explicitly hit that follow button and join us for future deep dives where we continue to break down the technical skills you need to advance your career.
As we wrap up this exploration, I want to leave you with a final thought regarding the trajectory of our industry. We have just spent the last hour discussing how design tools have fully absorbed concepts like inheritance, single responsibility, Git-style version control, and component props. 10 years ago, the line between what a graphic designer did and what a front-end developer did was a thick, impenetrable wall.
The designer dreamed it up and threw a static image over the wall for the developer to somehow build.
But as our tools evolve to mimic code, at what point does a designer actually just become a visual software engineer? That wall isn't just blurring anymore, it is actively being dismantled. Think about how you define your own job title and the skills you need to remain relevant tomorrow.
And as you think about that, remember, that static canvas is obsolete. We are architecting living systems now. Go build something scalable. Catch you next time.